Hello. This is the first of 4 laboratory sessions that will provide an introduction to the operational amplifier. In this exercise, Laboratory 5A, you will design and study the inverting amplifier. The pre-lab activities required that you design for a closed loop voltage gain of -2. And you're going to build that circuit up and you're going to test it and run some characteristic evaluations of the circuit. I want you to notice here that I've went ahead and did a design. And my design is clearly an inverting amplifier circuit because the input goes into the inverting input. And we have a feedback resistor of 20K and an input resistor of 10K. So the gain of that circuit is a -20K over 10K, which is a -2. I want you to notice that we're going to use a potentiometer out here. It explains that in the laboratory exercise. We're going to use a 5K potentiometer. We're going to set it up with a voltage of 10 volts. And the pickoff point here is going to slide so we can be adjusted so you can get 1 volt, 2 volt, 5 volts, or 8 volts at the input right here. And this is going to be our input out here. For this amplifier circuit, everything to the left of my pencil there is going to be the input. So I'm just going to have a separate wire coming off of here, and I've done that. You'll see that in a minute when I breadboarded this up. But what I want to show you is how you're going to, or where you're going to place that potentiometer to get this 1 volt, 2 volt, 5 volts, and 8 volts on the whiteboard, and how you're going to bias up the operational amplifier with the VCC and the VEE. So I want you to notice what I've done over. I have a dual supply sitting out here, and I'm setting VCC at plus 15 volts for this design, and I'm setting VEE at plus 15 volts. Both of these voltages get set to 15 volts. And I make a reference point between them. Though I'm going to explain that to you because that reference point between these two voltage sources becomes my ground rail here for the circuit. I'm going to show you where all this is at here. Notice if this is the ground reference right here, and I look at the voltage here with respect to the ground reference being here, it looks like a plus 15 volts, and that biases up to pin 8 for VCC of the op amp. If this is a ground reference at this point, and I pick off a voltage at this point, it sets up a -15 volts, which goes to pin 4 VEE of the operational amplifier. Now, how do I do that on the board? Well, this is what I'd like you to do when you build these circuits. First of all, I want you to notice is this top red rail that runs the whole way across here. I'm going to make this VCC. So I have a separate wire that comes in over here, and this is going to go to VCC. And I'll show you where that is on the power supply in a minute. This red rail here in the middle is going to go to VEE, and I'm going to make it red also. So I have 2 rails so far. I have this rail up here at the top, which is going to be my VCC of plus 15 volts. I have this red rail here that's going to be my minus 15 volts, VEE. And then the only ground reference rail I have on here is the one down here at the bottom. It's this blue one at the bottom. So there's my 3 rails. I have my top rail being my VCC, and that's where this is going to get connected to in a minute. I'll put it over here. I have this middle red rail being my VEE. It's going to go to the -15 volts. I'll put it over here right now. And I have this bottom rail here. There's my ground reference here, my black wire. And this point here is going to go, this wire here is going to end up going to my ground reference. I put my potentiometer down here at this corner. I put my operational amplifier up here. And I put my bypass capacitors out in here, and I'll explain that in a minute. I want you to put your pot down here, and I don't want you to use a rail when you set up that pot. I don't want you to tie up a rail for this 10 volts out here. I just want you to take 10 volts from the regulated supply of the trainer, which you're going to get right over here. Move this over so you can see it. You're going to get the 10 volts right out here using this potentiometer up here. And it's going to come over, and it's going to go directly to the potentiometer. And you can see that on the circuit right here. It's this wire right here. The other side of this potentiometer, because that's nothing more than a resistor, is going to go to ground. So I took the other side of the potentiometer and I took it to the ground rail right here. So that puts current flow in this potentiometer here to the pot, through the pot, back to ground. Now where's my pickoff point? This pickoff point right here is the third wire on the pot, and it's right here. It's this white wire right here, and I'm going to use that as my VN. That's my VN measurement right there. I also take that point and I run it over to my first resistor. That's this point right here. And then you go through that resistor and you can build the rest of the circuit. I only put this one resistor in right here, and I have it up here. The reason I'm positioning all this stuff over here is I want you to be able to get in here with the screwdriver and adjust this potentiometer, and I don't want anything in its way here. So I would put the resistor up in this area, run your second resistor over here if you have to, and then make it a bypass from the output to the input through white wires. But here's my operational amplifier. Pin 1 is going to be at this point right here. This is going to be pin 1 at that point. Here's pin 4, here's pin 5, here's pin 8. Pin 8 goes to VCC. You're going to see that from your own diagram. You're going to see that pin 8 goes to VCC, so I'm going to take it out to this rail up here. There's pin 8 going to VCC. Pin 4, which you can see here from your pin outs on your schematic, it's going to go to VEE rail. So I take it down here to VEE. So I have this chip biased up. This operational amplifier is biased up. I didn't build the rest of the circuit, but I have VCC gone to pin 8. I have VEE gone to pin 4. Now all I have to do is put these bypass capacitors in. If you take a look at the bypass capacitors, and if you read that one printout, that supplement that comes with Lab 5, you'll see that we put these bypass capacitors in, the 0.1 microfarads, which I'll give you, from the VCC rail to ground and from the VEE rail to ground. The easiest way to do that is the way I've shown you here. I put the one capacitor in from VCC to a point. I put the other capacitor in from VEE to another point, right here. And then all I do is jump the other side of that capacitor to ground, jump the other side of the capacitor to ground. Very easy to put these in the circuit if you just do it like this. So what do I have set up here? Well, right here I have my ground reference. I'll show you where that ground reference is going to go in a minute on the power supplies. I have my VCC up here, ready to go to the power supply. I have my VEE at this point right here. Right there's the wire ready to go to the power supply. And I have my ground reference down here on that blue wire ready to go to the power supply. Make sure that this point right here on your 10 volt regulated supply goes to ground. And I did that right here. I made this ground point a ground reference also. I mean, you have a couple grounds on here. This is a ground point out here between these two supplies on the dual power supply. And this is a ground reference over here too. You have to make sure that you make this connection to ground here as well. Now, how do I come up with my VCC and my VEE to bias this all up? Well, at Greater Allegheny, this is the power supplies that you have. You have a dual power supply. It looks like this. Here's where your VEE is going to be, between these two. Here's where your VCC is going to be taken from, between these two terminals. This is your ground reference, earth ground. We're not using earth ground. This is not an earth ground point right here. This is not an earth ground. It's a floating ground. It's not tied to earth ground. So how do you make a floating ground? Well, we just tie these 2 points together right here on the power supply. So this wire between here and here on this power supply just goes between this point and this point. It ties these two terminals together. It ties the positive terminal of what we're going to call VEE to the negative terminal of VCC. It ties the positive terminal of VEE to the negative terminal of VCC. That's this wire. That's your ground point right there. Now, you just set one supply up for plus 15 volts and you set the other supply up for 15 volts. Right here. all you're going to do is you're going to take this supply on the left side. Here's our dual supply. And you're going to set this up for 15 volts before you connect it to the circuit. Between this point being a reference and this point being a plus, there's your 15 volts. You're going to set this up for plus 15 volts. When you tie these 2 points together, you're going to jump this point to this point. You're going to make this connection. And then one of these are going to go to the ground, which is back here on the board. It's going to go to this ground connection. So this ground bus right here, that blue ground bus that runs across at the bottom of this whiteboard, comes back to one of these points. You don't have to throw it to both of these points because they're both going to be ground when you jumper these two together at the supply. And then if that's a ground reference and you're looking at this voltage here, it's going to be a negative 15 volts. That's going to be your negative 15 volts right here. It's going to go to pin, it's eventually going to go to pin 4, but it's going to go back here to this bus. It's going to be your VEE that goes to that bus here. And then you're going to take this point over here. This is your VCC supply. That point's going to be positive with respect to ground reference here. And you're going to take this point here back to the bus up here. You're going to clip it to the red lead that's coming off of the upper bus. So that's how you're going to do it with that supply. Now, if you didn't get that, let me show you the supply they're going to use at New Kensington. At New Kensington, we have these supplies, the Tektronix dual supply. And I want you to notice something. The earth ground isn't way over here. The earth ground is in between both of these. Here's your one supply right here. Here's your other supply value right here. This controls this point, and this one controls that point. We're not going to use earth ground. There's the negative terminal of one, the positive terminal of the other. Here's the negative terminal of one and the positive terminal of the other. Over on this one, they were side by side. Here's the negative terminal of the one supply, there's the positive, here's the negative, and here's the positive. All we're going to do with the New Kensington supplies is we're going to tie this point here to this point here. These 2 points get tied together. It's the positive of this supply to the negative of this one. Where's that at on the schematic? It's the positive of this supply right here to the negative of this one here. It's that wire right there. So we're going to jump a banana plug, it's probably the best way to do it, and tie these 2 points together. There's our ground reference. You take one of these points, not both of them, because they're the same point if you jump them together. You take one of these points and it comes over and it's the ground bus right here. It's this wire right here that you clip it to. And then you have your ground reference already set up on your board. And then you take the wire over here, which is going to be your VCC. Once you set this up for 15 volts, that's going to go to your upper rail. You're going to clip it to that wire. And then this, with respect to ground, is going to be a negative 15 volts. You don't try to set up negative 15 volts on these supplies. You set up 15 volts and 15 volts. Same thing with the other supply. You set them both up for the dual supplies up for both 15. And then if you want your VEE, you take it off the negative side. And that's how you're going to get your negative 15 volts at this point, if that's a ground reference. And this is how you're going to get your plus 15 volts if that's a ground reference. Now, a couple things I want to mention, no matter which supply you're using. You have to run these two supplies, these dual supplies, independently. So if you're at New Kensington, you want to make sure both of these buttons here are out, because that puts this supply independent from that. You can put them in series, you can put them in parallel, but we're not going to do that for these experiments. We want them to operate independently. And the other thing I want to mention is you can turn these currents down to current limit so you don't accidentally destroy the circuit or something. You could go ahead and turn these current values down until you start losing your voltage up here once the circuit's connected. That limits your current. That gives you a current limit. What I would do is just make sure that these aren't turned the whole way down. If these are turned the whole way down, you're not going to get any current coming out of the supply. So you can see that these are both turned up halfway at New Kensington. Same thing over here. You're going to have the same situation over here if you take a look at it, except you're going to do it over at this point. This sort of current limits you over here when you're reading the meter. So A matter of fact, on these supplies down here at Greater Allegheny, this just gives you the meter reading for the different values over here. You can read amperes, or you can read voltage at different scales. That's here. That's all this metering does on that those supply down at Greater Allegheny. If I'm taking a look at this, they're not giving you a current limit on this supply. So you just have to be a little careful with it, but we've never had any problem. I think it's internally protected. And you have to make sure this is independent again. You don't want to have this button up so A tracks B. You just go ahead, and I just go ahead and make sure this button here is independent. So this potentiometer here controls the voltage there. Just set it up for 15, and this one here sets up the 15 volts right here. And that's how you're going to set up these circuits. So a real quick review, no matter if you're doing design experiment 5A or 5B or 6 or 7, no matter which experiment you do over the 4 weeks we run these Op Amp experiments, I want you to go ahead and always make this top red one the VCC, make this middle red one the VEE, use red wires for both of those, or make sure you use red wires for both of those, their voltages. You know, in an ideal world, I might make this one the VEE green maybe, but we're not going to worry about that. We're going to make them red and just be careful. And then the bottom one is the bottom rail, the bottom blue one's going to be your ground reference. And even in the schematic that I did for you, if you take a look, you can see that I labeled the ground rail here. That's your ground rail that runs the whole way across. Multiple things get tied to the ground rail. Load resistor when we get to that part of the experiment. And then you have your VCC rail up here, and you have a wire. You don't go directly from there to the pin 8. You go from pin 8 to the rail. And down here's my VEE rail of your negative 15 volts. So we don't tie that directly to pin 4. We take the power supply to a rail, and then we jump from the rail to pin 4. And basically, if you take a look at the way I got everything connected up in here, the only other comment that I would make before you start running these labs is that if you notice, I have 2 wires here coming off the ground rail. I have this one over here, and I have this one here. One of them obviously goes to one of the points on the power supply, to one of these points on that power supply, or one of these points here if you're at Greater Allegheny, to give you your ground reference. The other one, what I would do, you're going to be using a multimeter to monitor voltages here, input voltage and output voltage. You're going to set input voltages and you're going to measure the output voltages. I would just have a white wire coming off of pin 1. If you look at your schematic, pin 1 is the output. So I would basically have a white wire coming off of pin 1 that you can monitor the output, and just take the black probe, the reference probe on the multimeter, and clip it to ground. Use an alligator clip and get it clipped to ground. And then you can just set that aside, and that'll be your reference. And then all you'll have to do is take the red probe on the fluke and just probe your voltages as you go through this. I don't want you holding both probes. That's ridiculous. You just keep the ground reference with the black one by clipping it here to the ground rail. And if everybody does this and builds their circuits consistently like this, it's going to be easy to troubleshoot. And we'll be doing a little bit of troubleshooting with it. I think I covered everything that I wanted to cover, so hopefully this gives you a good head start on these 4 Op Amp lab exercises. That concludes this brief lecture.